At 04:15 hours on August 9, 2025, a solitary Ukrainian drone cut a silent path through the pre-dawn darkness. Its mission was one way, a long-range suicide run aimed at the heart of Russia's largest military drone factory, a facility responsible for producing 500 drones every month that were subsequently unleashed to devastate Ukrainian cities. In 10 hours, this single aircraft planned to change that grim reality, but its entire future was contingent on surviving the next 30 seconds. The drone's flight path took it directly past a Ukrainian air defense position. It was a ghost on their screens. No IFF transponder broadcasting a friendly signal, no date to link chattering with identification codes, just a steady, unwavering radar return that looked, for all intents and purposes, exactly like an incoming Russian attack. The advanced radar of the Ukrainian Jeopard self-propelled anti-aircraft gun locked onto the target immediately, its twin 35mm Oerlikon autocannons swiveled with a low whir, tracking the contact with lethal precision. The fire control computer hummed, its algorithms already calculating the intercept solution. The target was now 8 kilometers away. Inside the vehicle, the operator stared intently at his glowing scope. The contact's signature matched the profile of a Bayraktar TB2. The Russians had captured several of these Turkish-made drones before and had turned them against Ukrainian forces. The operator remembered one such incident, a strike near Bakhmut that had used this very same approach profile. His finger hovered over the fire button. At this closing range, a burst of his tungsten cord rounds would shred any drone to pieces in a matter of seconds. Then a memory surfaced from the midnight briefing. A specific bizarre order from 0420 to 0430 hours: do not engage any aerial targets flying at exactly 150 meters altitude plus or minus 5 at a speed of 150 kilometers per hour plus or minus 10 through a very specific set of coordinates. No explanation had been given, no context provided. It was an order to be followed without question. He glanced at his watch. It was 0419, 1 minute until that mysterious window opened. The drone was now 4 kilometers away and closing fast. His fire control system displayed a chilling 94% hit probability. Every professional instinct he possessed was screaming at him to engage. The Jeopard system tracking the drone was a formidable piece of machinery. Those twin 35mm autocannons could pump out over 1,000 rounds per minute. Each advanced airburst shell was packed with 152 dense tungsten subprojectiles. The ammunition was designed to detonate at a predetermined distance from the target, creating a lethal, expanding cloud of metal precisely where the aircraft would be a fraction of a second later. No drone known to man could possibly survive flying through that kind of tungsten storm. The fire control computer continued its relentless calculations, but a nagging doubt was growing in the operator's mind. Ukrainian drones typically launched at night for strikes at dawn, not this early at 0415. They usually flew at high altitudes to avoid friendly fire, not down at 150 meters where virtually every anti-aircraft gun could easily reach them. The radar painted a clear picture, a 12-meter wingspan with a distinct twin-boom configuration. It was definitely a Bayraktar, or at least a very convincing replica. Yet this one maintained a steady Ukrainian approach protocol even as it flew relentlessly toward Russian territory. It was now 6 kilometers out. The drone held its course as if it were on rails. There were no evasive maneuvers of the kind typically performed by reconnaissance drones. There was no variation in altitude to avoid detection. It emitted no electromagnetic signals whatsoever. At a mere 150 meters, every Russian position along the front line would spot it the moment it crossed over. This was a profile of total exposure, a flight plan that made no tactical sense whatsoever, unless the drone had no intention of ever returning. At 5 kilometers, the clock ticked over to 0420 hours. The restricted window was now active. The operator's hands grew tense on the controls. If this was a captured TB2 now in Russian service, he had only seconds to stop it before it could cause havoc. But if this was a secret Ukrainian mission, his actions would destroy an operation of critical importance. The fire control computer still glowed with a 94% hit probability. 4 kilometers, optimal engagement range in just 5 seconds. Every fiber of his being was screaming to fire. But the parameters matched the briefing's orders perfectly. Exactly 150 meters. Exactly 150 kilometers per hour. Exactly through the specified corridor. Through his high-powered optics, he could now see the drone directly. His breath caught. This wasn't a TB2 at all. It was an An-196 Lelica drone. This identification could mean only one thing. The Lelica passed overhead at 0426, and the operator could only watch as it vanished into the darkness, heading for Russian territory. Morning reports would soon begin cascading through the command structure about a drone that, for some reason, had not been engaged. By 0630 hours, Sector Command in Bryansk had received 3 separate anomaly reports. Observation posts all along the border were reporting the same contact, a slow, moving drone at 50 meters altitude, heading 087 degrees, not responding to any electronic challenges, and not deviating from its course by a single degree. The tactical display showed a perfectly straight line pointing toward Nizhny Novgorod, and from there, the projection continued directly to Alabuga. The duty officer, recognizing the threat, ordered the immediate deployment of a Pole 21 system to a specific grid reference. The Pole 21 is a sophisticated GPS jammer, essentially a powerful mobile broadcasting tower mounted on a military truck. Its 15-meter antenna mast radiates 1,000 watts of pure electronic noise across all major GPS frequencies. It creates an electronic bubble 20 kilometers in diameter where satellite navigation simply ceases to exist. Its signal strength hits incoming drones at -90 dBm, while the genuine GPS signals from space whisper at -130 dBm. The jamming signal is 10,000 times stronger, the electronic equivalent of trying to hear a whisper while standing next to a roaring jet engine. The An-196 entered this zone of electronic darkness at 0634. The Pole 21 operator watched his scope, mentally counting down the expected sequence. 3 seconds for the jamming to overwhelm the drone's GPS receiver. 5 seconds for the drone to recognize the total signal loss. 10 seconds to begin its lost link protocol, which would typically be circling or returning to its home base. At 8 seconds, the drone wavered slightly, a tiny wobble as its internal inertial navigation system tried to compensate for the lost satellite data. At 10 seconds, it should have begun its turn. It didn't. It steadied itself and continued flying east, utterly unfazed. The operator, puzzled, switched from jamming to spoofing mode. Now the Pole 21 began broadcasting sophisticated false satellite signals, designed to convince any GPS receiver that it was actually 500 kilometers from its real position. The drone would be expected to start correcting its course toward this phantom location, gradually flying off course until it ran out of fuel. The Lelica ignored the false signals completely. A later analysis of its flight path would reveal something terrifyingly sophisticated. The drone wasn't simply following a railway or a road. That would be too predictable and easy to ambush. Instead, it was using a complex sequence of visual terrain references. It would follow the M3 highway for 10 kilometers until a distinctive S-curve near a town called Selzo, then adjust its heading 15 degrees north. It would then track a set of high-voltage power lines until they intersected with a river, crossing at a specific 3-span bridge avoiding a nearby two-span one. Each waypoint was chosen for its uniqueness, making misidentification impossible. This was pure visual navigation, meaning the drone was operating in complete autonomy. There was no GPS signal to jam, no remote control link to override. The Russians had spent $8 million per Pol 21 unit, investing thousands of engineering hours into perfecting GPS denial. Ukraine had defeated it with a simple, yet brilliant concept. They had taught the drone to look where it was going. The alert was subsequently passed to an S-400 air defense battery near Nizhny Novgorod. A drone was inbound, estimated time of arrival 0945. A preliminary warning was also sent to Alabuga. A possible drone incursion, moderate confidence, estimated arrival at 1,150 hours. By 0800, Russian electronic warfare operators were tracking an anomaly that defied logic. A drone navigating with pinpoint precision through a GPS blackout, following highways, rivers, and power lines with the unerring accuracy of a tourist possessing a perfect, memorized map. Each visual checkpoint brought it inexorably closer to Alabuga, where 500 shod drones were stored in warehouses awaiting their deployment over Ukrainian cities. At 0945 hours, the S-400 battery near Nizhny Novgorod had been monitoring the anomaly reports for 3 hours. Bryansk had reported losing a GPS-immune drone heading their way. Now it was their turn to find it. The key to the S-400 system is the 92N6E gravestone radar, its all-seeing eyes. The panels of this radar contain 10,000 transmit-receive modules, pumping out 100 kilowatts of focused energy in the S-band. Against a fighter jet with a radar cross-section of 3 square meters, its detection range can reach an impressive 250 kilometers. But radar physics are brutally unforgiving to small targets. The N-196 presented a radar cross-section of only 0.5 square meters, 6 times smaller than a fighter. The detection range doesn't drop linearly. It follows the fourth root of the radar cross-section ratio. This complex mathematics collapses the detection range from 250 kilometers to just 107. To make matters worse, the drone was flying at a mere 50 meters altitude, using the Earth's curvature and ground clutter as a shield. At 0945, the drone briefly climbed to 200 meters to clear a ridge. The powerful gravestone radar locked on immediately. Slow-moving UAV bearing 262, range 89 kilometers. The classification was unmistakable. A 12-meter wingspan twin-boom configuration, likely a TB2 Bayraktar. But the location was impossible. Turkish drones had a known operational range of about 300 kilometers, and this contact was already 900 kilometers from Ukrainian territory. The timing of its appearance was also disastrously perfect. The battery was in the middle of its shift change at 1,000 hours. The overnight crew had 13 minutes left on duty, already mentally checking out and thinking of rest. The day crew would not be fully oriented and ready for critical decisions until at least 1015. This created a 15-minute gap where institutional reluctance to make major decisions was at its peak. The track on the screen showed a perfect, unwavering straight line heading directly for Alabuga. This was not the wandering, searching pattern of a reconnaissance mission. This was the determined, straight-line navigation of something heading for a specific target. This is where the relationship between the S-400 and its accompanying Pantsir air defense systems became critical. The S-400 is designed to handle long-range threats with its massive and expensive 40N6 and 48N6 missiles, each costing around $2 million. These are reserved for high-value targets like aircraft and cruise missiles. For closer-in protection, the Pantsir systems provide a shield with their 30mm autocannons and shorter-range missiles. The systems are meant to work together, sharing data and creating overlapping fields of fire. But the combined system had a critical geometric flaw. The Pantsir's guns could not depress below an angle of -5 degrees. With the drone at 4 kilometers range and flying at 50 meters altitude, the angle required to hit it was -7 degrees. The drone was literally flying underneath the Pantsir's guns. The expensive long-range missiles were, by doctrine, reserved for larger, more valuable threats, and the cheaper autocannons that could logically be used against a drone simply couldn't reach it. As the contact descended back to 50 meters, it vanished completely into the radar ground clutter. Ground clutter is radar's eternal blind spot, the chaotic mess of reflections bouncing off trees, buildings, and terrain that creates a wall of static where the earth meets the sky. The drone disappeared into this electronic haystack. The overnight supervisor, eager to end his shift, made a simple log entry: possible UAV contact bearing 087, assessed as reconnaissance, lost in ground clutter, no action taken. By 1015, when the day shift finally reviewed the logs, the Lelica was already 40 kilometers past their position. The new operator checked his scope, saw nothing but the usual morning thermal false returns, and dismissed the earlier contact entirely. The warning to Alabuga was now updated: confirmed drone approach, high confidence, arrival estimated at 1,150 hours. Multiple, layered Russian air defense systems had failed to engage the intruder. The counter-drone operators at the Alabuga factory itself began preparing their specialized systems. They had purpose-built technology designed specifically to stop drones, and they were confident it would succeed where the traditional air defenses had failed. At 1,147 hours, the counter-drone station at Alabuga had been tracking the inbound threat for hours. They had the reports from Bryansk about the GPS jamming failure and from Nizhny Novgorod about the radar contact. Now it was here, 8 kilometers out, climbing through 250 meters and flying straight at them in broad daylight. The system they relied on was the repellent one, a platform built for one purpose: stopping drones. Its directional antenna focuses 500 watts of electromagnetic energy into a narrow 30-degree cone, overwhelming any drone command receiver within 2.5 kilometers. The system's computer contains a library of 10,000 command protocols. Every frequency, every standard, every override command ever used by military and commercial drones, from Turkish military bands and NATO standards to Ukrainian protocols and even Chinese commercial codes. The operator activated the system. A torrent of 500 watts of electromagnetic energy slammed into the drone. The system cycled through all 10,000 override commands in just 4 seconds. Asterisk, return to home, land immediately, enter hover mode, switch to manual control, emergency stop. Asterisk, every possible command, transmitted in every possible format. The N-196 flew on, unchanged, straight, level, and utterly mechanical. A frequency, hopping attack was the next tactic. The system began hitting specific frequencies at microsecond intervals, trying to catch the drone's receiver in the brief moment between its own frequency hops. This technique had glitched even encrypted military systems before. There was no response. The drone was now 5 kilometers away and closing. A Serb VSS-5 GPS spoofer joined the assault, broadcasting incredibly powerful false satellite signals that created a phantom position 500 kilometers away, then gradually walked that false position back, a trick designed to fool the drone into making a gradual turn. This tactic had never before failed against a GPS-guided system. The drone maintained its course. At 3 kilometers, a horrifying truth was becoming clear from the analysis of its approach. The drone was following visual landmarks: the main road to a specific water tower, an adjustment at a particular railway junction, a correction at a sharp river bend. This was pure optical navigation, comparing the live camera feed to stored imagery. But that wasn't the most frightening part. Intelligence gained from earlier models revealed the drone's secret. Inside its airframe, the standard sensor ball had been removed. The satellite communication dome was gone. The antenna arrays were cut off. In their place, extra fuel tanks had been welded. The control receivers weren't just disabled, they had been physically ripped out. Antenna cables were cut and capped, radio modules entirely uninstalled. There was no radio frequency pathway left into the flight computer. They were trying to hack a machine that had no ears to hear the commands. It was a flying brick, guided only by its eyes and its pre-programmed brain. As a last desperate measure, all jamming stations switched to barrage mode. 14 jammers opened up simultaneously, creating an electromagnetic storm from 100 megahertz to 6 gigahertz, 50 watts per megahertz of pure, unstructured noise that should crash any unshielded processor through induced electrical currents alone. But the drone's flight computers, wrapped in carefully engineered aluminum Faraday cages, were completely insulated. They didn't register even a flicker of interference. Inside the drone, a simple final command was executed. Asterisk waypoint 1146 achieved. Proceed to waypoint 1147. Initiate terminal dive. Asterisk at 1152 hours, high noon, the N-196 slammed through the factory's anti-drone steel mesh at 180 kilometers per hour. The lightweight grid, designed to stop 5-kilogram commercial quadcopters, sheared instantly against 700 kilograms of accelerating aircraft. The drone penetrated the warehouse roof, and its thermite warhead detonated. The chemistry was instant and devastating. Iron oxide plus aluminum powder yields pure iron and aluminum oxide, releasing temperatures of 2,500 degrees Celsius. A stream of molten metal poured into the tightly packed storage racks holding the shod drones. The first drone's fuel tank ruptured in 0.3 of a second. The vaporizing fuel expanded with a ratio of 8:0 to 1, creating a massive building over pressure. Within 2 seconds, 50 drones were exploding in a rapid, sympathetic sequence. After 8 seconds, the warehouse roof structure failed completely under the force of 3 atmospheres of pressure. At 15 seconds, the north wall blew outward. In just 30 seconds, all 500 shod drones were consumed in the inferno. A colossal fireball climbed 800 meters into the sky. The overpressure from the initial blasts shattered windows 5 kilometers away. 6 months of Russian drone production, representing nearly $500 million of Iranian technology and Russian manufacturing effort, was vaporized in under a minute. One long-range, autonomously guided drone had just proven a profound and terrifying new reality of modern warfare. In the emerging age of autonomous systems, the most sophisticated and expensive electronic defenses in the world could be rendered utterly useless, becoming nothing more than expensive systems shouting commands at a machine that was built, quite deliberately, to be deaf.